getting rid of fractions, correct?
Yes.
Which I think some of you were like, wait a minute, that just took something from an unreal situation to something that you feel you might be able to do. But let's go and work these problems. You stop me. You pause me if you're not sure. All right, so that's problem number 1. Talk to me, friends. Yeah, so you distribute over. So 5 times x, 5x. 5 times 7 is 35 equals 200. Dude. That's my phone. Subtract 35 from both sides, right?
Yeah.
Cool. Those are gone now. Good.
And then you get 33.
33. I like it. So that's the solution to the problem. Okay. Now, I worked a problem similar to number 2, correct?
Yes.
But did I actually work number 2? No. Okay, I couldn't remember. I did work it?
Oh.
Kind
Oh,
of?
yeah, you did. Oh, yeah, you did.
I did? Okay. Let's just work it just to get our minds in the right spot. So I have a over 2 plus 5 over 4 equals a. I can make a better a than that. Minus 3 over 4. Okay. So we said that, like, if you want to work this problem, first off, we all agreed yesterday that if this was something on a test, it's going to get left blank.
Yes.
But then I showed you that if you were to say, you look at your denominators, which are 2 and 4, you have a 2, a 4, and a 4. So 2 goes in a 4, and 4 goes in a 4. Agreed? So I'm going to make that 4 over 1, that by 4 over 1, that by 4 because it's not a fraction, that by 4 over 1. And if I do this, that 2 goes into that 4 twice, so 2 times a is 2a. This 4 cancels this one, and so I get 1 times 5, which is 5. 4 times a is just 4a, and that cancels that, so negative 3. So this becomes a problem that probably wouldn't be one that people would skip because, well, we don't have the enemy, the fraction up there. Agree?
Mm-hmm.
Do what?
I don't get what to do.
Okay. Are you okay to hear, or is it up here that we're... Okay. So you agree with me that 2 and 4 are the bottom numbers. Are you okay with that? And do you agree that 4 goes into 4 and that 2 also goes into 4?
Yeah.
So we're good with that. We're solid. Like that's not where the disconnect takes place, right?
I mean, but like, why does 2 go into 4?
Because 2 times 2 is 4. Right? It's a factor. So if I were to, here, let's do it off to the side. So if I were to take the 2 and I'd go 2 times 1, 2 times 2, 2 times 3, 2 times 4. You agree with that? And if I did the same thing with the 4, 4 times 1, 4 times 2, 4 times 3, so on and so forth, this number here and this number here mean that 2 and 4 are both factors of 4, meaning I could multiply 2 whole numbers with each other to somehow get to 2 or to 4. Okay, is that clear?
Not really.
Okay, you're okay with 2 times 1, 2 times 2 times 3. So you're okay with how I generated the list, right?
Where do you get the 4 from, though?
So which 4, green or black?
3.
Green over here on the far. It's because it was right there and right there. It was one of the denominators. Okay? So basically, how I generated each of those lists And I didn't have to go too far. And then I did 4 times 1, 4 times 2, 4 times 3. And that's how I got the list up above. And then I look at the list and say, on my list, are there, the closer I am to the top, so this has a 2 right here, but there's no other 2, so I can't use 2. And then I go down and say, okay, I have a 4 next, and I have a 4 here. And we can literally stop right at that point because those 4s match. And that means if I take that 4, and we have to understand that 4 is equal to 4 over 1, that means the exact same thing. Agree? And so from there, we're going to realize we're either going to multiply by 4 if we don't have a fraction, or 4 over 1 if we have a fraction. So this was a 4 over 1 because I have a fraction. This was a 4 over 1 because I have a fraction. This was just a 4 because I don't have a fraction. And this was 4 over 1 because I have a fraction. And when you multiply fractions together, you could reduce first before you did anything. Usually on a fraction, you multiply top to top, bottom to bottom, and then reduce. Or you could reduce before you do anything. So this 2 goes into this 4. This cancels out and leaves me a 1. This cancels out, leaves me a 2. And then I just go 2 times a to get there. Am I okay on the explanation so far there? Talking to you? Yeah? Okay. And then from here, this is a 4 over 1. 4 goes into itself once. 4 goes into itself once. Then I go 1 times 5 to get to this 5. So it's called clearing a fraction. So let me advance. We'll come back to that problem. I want to show you this real quick. Ready? Similar type of problem. Fractions are among us. Okay? So if you think about this, if I went and tried this problem, I'm going to get some nasty fractions. My answer is still going to be a fraction, but I don't have to deal with it all the way through. Yeah. Yeah, please hurry. Okay, so what we can do here is I realize I have 3 and I have 6 as my 2 bottom numbers. So 3 times 1, 3 times 2, 3 times 3. 6 times 1, 6 times 2, 6 times 3. What number in that blue list under the 3 and the 6, which number is the same? You okay with that? You agree that? Well, I mean, you can identify a 6 and a 6?
Yeah.
Okay. So, but do you see how they're the same? Like, I'm not using the very top 3. I'm not using this 3 right here because I don't have a 3 over here. I'm looking to see, where do I have the same? I have 6 and 6 are the same. 9 doesn't work. 12 doesn't work. It's not in there. 18 is not going to work because it's not in there. So I'm going to use the smallest number that both 3 and 6 would go into. And when I say 3 and 6 would go into it, I would say this. If I had this, do you feel comfortable that the answer would be 2? Because 3 goes into 6 twice.
Yeah.
And then if I had this, I'd get 1.
Yeah.
Does that make sense? So if I were to go, because I'm using both those 6s, and I said, if I multiply this by 6 over 1, I can't just multiply one thing. I have to multiply everything. And this one over here, all I'm going to multiply this by is 6 because that's not a fraction. Does that make sense? And then you can just start reducing from there. You can say, you know what, this bottom 3 is going to become a 1. 3 goes into 6 twice, and 2 times that 2 is going to give me a 4. And then I have this plus sign. 6 goes into itself once. 6 goes into 6 once. 1 times 5x is 5x. And then I get 18. So the pink original problem versus the blue problem that's now on the board are the same problem. It's just this one doesn't have a fraction. This one looks like a lot friendlier to try and work out than this.
I forgot how to solve the blue
Okay, we're gonna get there. So, have you followed from pink to blue? You feeling like 5 or 6% more comfortable?
Yeah.
I'm not saying 100%. I'm not saying you're gonna. I mean, this skill here is a skill that we will institute for the entire year.
Yeah, I think I get it.
Okay. So if you go and work that out, we're gonna get there. So what I want to do is I want to go back to the problem I had there originally. Okay. We're doing the same idea. So this green problem that has things crossed out in it is now this purplish color problem, which there's no fractions here. Okay, I can work this out using the fractions, and I'm going to get the same answer, but it's a lot less friendly to try and work out when you're adding and subtracting fractions. This one, I don't have fractions in, and it's going to work out to the same exact answer. It's just a matter of understanding of, can I get rid of something that I don't need? And then from here, that dotted line means the equal sign continuing down. And then we can start doing some stuff. Maybe I decide I have a positive 2a. Maybe I decide I have to pick some place to start. I'm just going to pick here. That cancels to get there. Checking in with every fist of 5. You're good up to the problem I'm at. 4. Cool. Fist of 5s. Good, good, good. I didn't see it. Go ahead. Okay. So from here, we want to get the a by itself. So I feel the next move we would want to do is add 3 to both sides. So that's going to cancel there. I'm going to get 8 is equal to 2a. Okay? And again, it's the same problem. It's just we're moving things back and forth across the equal sign. And my last step here would be divide both sides by 2. And then we have to decide, does 2 go in? Does the bottom number go into the top number? And it does. It goes in there 4 times. So I wind up getting an answer of a equals 4. Yeah.
Wait, you divided by 2 because 2a is what it is right now?
2a is 2 times a. So right now, 2 and a are multiplied together. And the
Let's say it was like 4 and you divided by 4.
yes. Yep. So you're just doing, and the reason you're doing division is that is the reciprocal or the inverse operation of multiplication. Like addition, the opposite operation of addition is subtraction. Multiplication, the inverse operation is division. Okay, cool. All right. How's that next problem up there? Number 3 look. It's, yeah. 6n equals, yeah. Can you wait till Frank gets back, please? Is that cool? Thanks. All right. Hey, thank goodness, no fraction. Agree? Cool. No fraction. So talk to me, friends. What do you feel you should do? Yeah, we're going to multiply over the parentheses. Awesome. Now, this problem is a little bit goofy. Okay? Notice on the right side, I have a 4n and I have a 2n. Do you agree? And if I add those together, I wind up with 6n plus 20. So I combine my like terms. Yeah, so then all of a sudden, watch what happens. Wait a minute. Wait a minute. Did we just solve one of the great mysteries of the world of math? That 0 is actually equal to 20? Or does that seem like total nonsense? Total nonsense. This means we have no solution. Yeah, you got it now. Yeah. Well, if I wanted to keep the n alone, you're absolutely right. If you wanted to keep the n by, on that side, totally. But because I have it on either side, if I subtract it, bring it over, that happens to cancel. They happen to cancel on both sides. And you get this really strange anomaly. And you know as well as I, if I were to say, here, I'm going to give you 0 money, or I'm going to give you $20, which one are you going to choose? 20 all day long, right? It's like, nah, I don't need anything. But that's, so once you get to something that you know is so obscurely wrong, because you know that one number can't equal another number, it just automatically goes to something called no solution. Okay?
Can you do number 5?
I sure can. Can I do 4 first? Number 4. Okay. Before I start doing anything on this particular problem, I have something in parentheses. Agree? Okay. Now, before you tell me exactly what to do, let me highlight something first, and you tell me if you can comprehend. Do you see that -3 right there?
Yes.
Now, my friends, I can't on this problem, I cannot go 12 minus 3 to get 9. The reason I can't do that is this 3 is attached to the parentheses. Do you agree with that?
Yes.
Which means I have to now distribute over the parentheses -3. So then I get 12 minus 3x plus 9 equals 12, or equals 9, excuse me. Stop there. Is that okay? Okay? What is special? What is special about here and here? Yeah.
Is this part gonna be on the quiz?
You might see this. What's special about the 12 and 9? Are they on the same side of the equal sign or opposite sides? Same side. So what do we do with them? We combine them together. Good. In this case, we're going to add them. Good. So 12 added to 9 is 21. Minus 3x equals 9. Okay? And then you think you want to subtract 21? This is a positive 21 as it sits. Do the opposite. That cancels. Is it okay that we get, if we combine those together, that we wind up with a negative 12? Is that okay? Now, how are these being held together? Bless you. Multiplication. So I'm going to divide both sides by -3, and I get a positive because a negative over a negative is positive. So that makes it positive. 12 over 3 is just 4. So that kind of a monstrous event is just going to give me an answer of 4. Huh. Yeah. Yeah. Thanks. All right. Someone asked about number 5. Number 5. Oops, plus x. Okay. Yeah. Yeah. 2 sets of parentheses, agreed? You need number 4's answer? Is that number 4 right there? Right there? Frank, does that work? All right. What should I do with this 3? Yeah. What should I do with this -2? Yeah, good. So if I multiply, I get 15x minus 27 equals -12 plus 4x plus x. What should I do over on this side? Add the x's. Very good. And subtract them, right? So now we have to make a choice. And it doesn't really matter where you start this one. but I have to somehow maybe move the x over. So I think, what do you think? Yeah, let's subtract the 5x. We can do that. We could have subtracted 15x, but this is where we chose to start. A Band-Aid? I do. 3? You got it. Be right back. Actually, funny thing, I snagged a whole box this morning. Frank, I'm going to give you 4 just in case, and you get something in your ear. And it's not the earring. It's the other side. All right. What should I do now that I'm down the blue? I have 10x, minus 27, minus 12. Okay, I want to get x by itself, agree? So if I want this by itself, yeah, good job, plus 27. And I think if I do my math correctly, this is going to come out to 15. Did I do that right? Some cost $12. I have 27 in my pocket. I pay for it. I walk out with 15 in the product. All right. Divide by 10, divide by 10. So I'm going to bring it over here. X equals. How do I get 3 over 2? Yeah, I reduced the fraction. 5 goes into 15 3 times. 5 goes into 10 twice. I get an answer of 3 over 2. Hey, friends, is it okay to leave answers as improper, meaning the top number is bigger than the bottom number? Yeah, and I'm really disturbed that elementary school makes you change it to mixed numbers, because mixed numbers are no-nos in math. Leave it as an improper. You don't have to say, oh, it's 1 1/2 or it's 1.5. Yeah. Tape? I have that too. Yeah.
How did you get positive 4x? Has to do with being multiplied by negative. Negative.
Oh. Negative times a negative is a positive. Tape. Where's my tape? I found my tape. It's in the last drawer. I started looking. This is once I find it, I stop looking. All right. We're almost done. Last problem to talk about. Okay. We're there. Comfy? All right. So let me ask you. I feel that a lot of you might say, distribute the half over the parentheses. Agree? And I think that's a good move. Whoa. Don't cancel. Don't cancel. All right. Ready? So I could distribute over. But I want you to think about this for a moment. I have this whole side that's all together. And I have this side by itself. Agree? Ready? Remember what we had done with fractions before? Watch this. If I multiplied this by 2 over 1 and this by 2, watch what's going to happen. 2 cancels here and here. Distribute 1 over the parentheses, so I get this. And it's equal to 14. I no longer have to worry about the fraction. Just kind of a trick to the trade. So let's subtract 5 from both sides. That's gone. Nine over 2 is a fine answer. Woo! Yeah, baby. Okay. So, my friends, I won't be here on Monday. I wish I was. I don't like missing school. And they're like, you have to be at this district meeting. Throw up in my mouth every time I say it. Okay. Will you find me? Let's just take a look at this. And I think I have to make, do you have this page by chance? Or did my packet not go far enough?
It's page 7.
Page,
Or day 7, I mean.
day 7,
Page 13.
page 13. Does it have a 13 at the bottom, on the very back? Keep going. Oh, okay.
12.
I have to make you a copy. Okay, but I'll get you one before we leave. But will you do me a favor? Will you remind me you need a copy of that page because I'm gonna forget. And you need a copy of that page too, right? Okay. So let me just show it real quick. And I'm pretty sure you should be okay with it. All right. XY axis, agreed? Agreed?
Yeah.
Okay. So, I just want to kind of go briefly and talk about our A value, B value, our C value, not writing anything down today? We're in school. Yeah. I will make you a copy. Remind me. She has to remind me, he has to remind me, and you have to remind me. Okay. Let me just show, and I'll leave this up on the board. So then you can just copy it down once I make the copy. Deal? All right. All right. If someone's got some music going, and it's not me.
Can I help you? That's so sassy. Oh, my bad, my bad.
Yeah, and earbuds are non-negotiables in my class. Thank you. All right. So the first one, -4, 1. That's point A. Agree? Letter B, -3, -2. That's B. Letter C is 5, 3. Okay, so we're just plotting points on this worksheet, or we might be asked to find some points on the page. Okay, so friends, the entire page 13 is what I'd like you to work on. Okay? You have the rest of the period to knock it out. If you get it done, giddy up. Okay, but I have to go make a couple